Hello again and welcome to another flipped classroom. Today we're going to be having a look at the quadratic formula. Now, so far in this chapter we've had a look at a few ways of solving quadratic equations, starting with factorizing, then moving on to factorizing using completing the square, and today we're probably going to look at one of the easier ways, which is using the quadratic formula. Now, the thing is, with a lot of these methods that we've shown you so far in this particular chapter, a few of them, well actually a lot of them, are actually related to each other in some way, and in fact the methods that we use to solve a quadratic formula are sometimes derived from the formula or the method used from another completely different technique. And the same goes with the quadratic formula. Now, I've done this earlier to save a bit of time, but basically, if we have a look at the general form of a quadratic, that means the thing that I've put on the board a couple of times, this ax squared plus bx plus c equals 0. So the a, the b, and the c all equal just random numbers. Now, what we can do is, for the previous exercise, we learnt that if you can't factorize a question normally to solve it, then we can solve it using the completing the square method. Now, if we take this general form and we solve it using the completing the square method, that should, in theory, give us an answer that we can use for all quadratic equations, a formula that helps us solve each and every equation without the need to factorize, without the need to solve using completing the square, because we're using this general form, and this general form is an expression or an equation that we use to represent all quadratic equations. So what I've done here in the green is I've actually solved this general form using the completing the square method, and I've come up with an answer down the bottom here which shows us what x will equal for all quadratic equations if we simply substitute the values of a, b, and c into this formula here. Now, I'll quickly run through it to show you exactly what I've done, but if you can do it by yourself, that's really going to help you out in the long run. So what I've done is I've solved using the completing the square method, and you remember that in the examples that we did for completing the square, whenever there was a number in front of the x squared, we removed it as a common factor, or we divided all of these by that number to remove it from the question. So that was example 2 in exercise 4C, I believe. So what I've done in the first line of working out is I've removed this a term by dividing them all by a. So the a gets removed from the first one, each of these gets divided by a, and 0 doesn't get anything because 0 divided by a is still just 0. Okay, now that I've got it in this form, I started doing my completing the square method. So the first step I did was I subtracted c over a from both sides of the equation to give us this line of working out. So I moved it from one side to the other side. Then what I did was, the next step of completing the square is to halve the term, the coefficient of x, and square it. So over here, over the right hand side of the equation where I did it in the previous PowerPoint, I've done my working out here. So I've taken the term b over a and I divided it by 2, and that's just the same as saying b over 2a, and then I squared it to get me b squared over 4a, and I put it in here because the next step was to add it to both sides of the equation. So my answer I just took over here and added it to the left and the right hand side of the equation. Now my next step, we had to factorize and simplify, or factorize the left hand side and simplify the right hand side. So I'll show you what I did. So to factorize, remember it was always this number inside the brackets before we got to our answer, and it was always x plus that squared. And then over on the right hand side, I was simplifying by making because I'm adding two fractions, I made a common denominator of 4a cubed, and then I cross multiplied to give me my numerator up the top here. Alright, then it was just a case of simplifying still, because I'd factorized my left hand side. So on the right hand side, I took out a common factor of a from the numerator, and then I cancelled an a from the top and an a from the bottom, so this stopped being 4a cubed and it was just 4a squared. And that left me with x plus b over 2a squared in brackets, and that equals b squared minus 4ac over 4a squared. Okay, then I continued to solve using the completing the square method. So I took the square root of both sides, and when you square root a fraction, remember you square root the top and the bottom of your fraction. And also remember, when we were completing the square, if you take the square root of the left hand side and then take the square root of the right hand side, first of all our squared gets removed, but also it adds this plus and minus to the front of your equation. So plus or minus, we talked about that in the last class. Okay, now what I did then was I simplified the denominator, because I noticed that on the bottom the square root of 4 is just 2, and the square root of a squared just cancels out the squared. So I was left with 2a on the bottom. Alright, also in that same step, I moved this b over 2a over the other side, and so I got minus, because I subtracted b over 2a from that side, and I subtracted b over 2a from this side, and I got the previous fraction, and then it's just the minus b over 2a from here. Now, because these already have a denominator which is the same, that means I could immediately subtract b from this fraction and join them together, and my complete answer was minus b plus or minus the square root of b squared minus 4ac over 2a. So this can be used for all questions to solve a quadratic formula. And here it is. Minus b plus or minus the square root of b squared minus 4ac. So this formula, it's good to know where it comes from rather than just being given it and go, alright, well, I'll just use this to solve any quadratic formula. This was derived from the general form of a quadratic equation, so all quadratic equations, by using the completing the square method, which you learnt in the previous class. Now we're going to use this formula to help us solve the examples on the following page. Example number 1. Solve the quadratic equation 3x squared plus 4x plus 1. Okay, so here's our formula. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. So that equals, remember, a is the first one, so this is a, this is b, and this is c. So minus b, so minus 4 plus or minus the square root of b squared, so 16, minus 4 times 3 times 1 over 2 times 3. Now you can pretty much do that in your calculator, but I'll just show you the steps of simplifying it from here. So that's minus 4 plus or minus the square root of 16 minus 12, so 4 over 6. Now that equals minus 4 plus or minus, well, the square root of 4 is just 2 over 6. Now that means we get two answers, because don't forget we go minus 4 plus 2, and we could also do minus 4 take away 2. So x can either be minus 4 plus 2, which is minus 2, divided by 6, which is minus 2 over 6, which is minus 1 over 3, or x can equal minus 4 take away 2, which is minus 6 over 6, which just equals minus 1. We still get our two answers, and that's derived from the plus and minus sign in the middle. Alright, let's have a look at our second example. Remember, this is our A, this is our B, and this is our C. So start off by writing the quadratic formula. X equals minus B plus or minus the square root of B squared minus 4AC over 2A. And this equals minus 12 plus or minus the square root of 12 squared, which is 144, minus 4 times 3 times minus 3. Don't forget to put those plus and minus signs in correctly. That's over 2 times 3. Alright, let's simplify this a little bit more. So minus 12 plus or minus the square root of 144 minus 4 times 3 is 12, times minus 3 is negative 36, so 144 minus negative 36, and that's over positive 6. Okay, and that equals minus 12 plus or minus the square root of 144 plus 36 gives us 180 over 6. Okay, so grabbing your calculators now, the square root of 180 gives us a decimal place. So we're not going to write that in just yet. So x is going to equal, so we're going to do first minus 12 plus the square root of 180, and then we'll divide that by 6, and that gives us our first answer, because we're going to two decimal places, 0.24, or if we do the minus 12 take away the square root of 180 divided by 6 gives us an answer of minus 4.24. Okay, and that's our two answers. I hope this has explained how we get the quadratic formula and how to use it. As far as I'm concerned, this is probably the easiest way of finding the solution to x. And now you have in your arsenal all the different ways of factorizing and solving quadratic equations, starting with factorizing, then completing the square, and now finally the quadratic formula. All right. If you need some practice questions, please make sure you come and see me in class. I didn't put any in this particular slideshow because I didn't think that you would need them, since it is a fairly easy exercise. Nevertheless, if you have any questions, come and see me tomorrow in class. And as always, I'm Mr. Rappell, and I will see you tomorrow. Bye.